Hey guys, welcome to part C, homework review, reviewing work with integers and this time word problems. I started off easy and then they get up to the state test level. A scuba diver starts at a height of 10 feet above sea level. He then dives down 25 feet. Remember that integer problems can be thought of as adding and subtracting. So when we're thinking about our starting point, that's like a first number in a number sentence. And then the direction we're moving is like addition or subtraction. So in this case, diving down is subtraction. And then how far we dive down is like the next number. And the answer is going to be wherever the final altitude is. So if we start at 10 feet above sea level and then we're going down 25, well, that's like 5, 10, 15, 20, 25. That should take us to negative 15 feet, or 15 feet below sea level. Alright, so same context. After encountering a shark 20 feet below sea level, so that's right here, the diver swims up 20 feet. So I'm sure a lot of you saw that, and it was pretty obvious that he'd end up at sea level. But just to check it, if we're at negative 20, we can go up 5, 10, 15, 20. And if we were to write a number sentence for it, it's like starting at negative 20, or 20 feet below sea level. Swimming up is like addition, and we're swimming up 20 feet. And we would end up at 0. And thinking about it, if we had 20 negative chips and 20 positive chips, they'd all cancel out. So that's another reason why the answer should be 0, or 0 feet. Alright, so more realistically, on the state test, you're not going to be given helpful pictures with number lines on them. You're going to have to represent it in your own way. So let's take a look at some of those problems. The temperature on Monday reaches 24 degrees. After a snowstorm hits, it drops 30 degrees. What's the new temperature? So if we want to put this together into a number sentence, we have our starting temperature of 24 degrees. We see that the temperature is dropping, so we're going to be subtracting, and it drops 30 degrees, so we're going to subtract 30. You might look at this problem and you might, after working with integers, already have a shortcut, which you could totally use, but just in case you don't, here's something that will always work. An open number line. So the temperature starts at 24 degrees, and then it's going to go down 30 degrees. I see that since it's going down more than 24, I know that we're going to go past 0. And I know that 24 down to 0, that means we've already gone down 24 degrees. And if you think about it, how much left do I have to go down a total of 30? Well, you could have subtracted, and if you did that subtraction, you should get 6. And that makes sense because 24 plus 6 is 30, so that means we have 6 more to go down. And since we ended up below 0, our answer would be negative. So the temperature was, after the snowstorm hit, negative 6 degrees Fahrenheit. And the shortcut I'm sure some of you used for this type of problem is basically just doing this and then just thinking, oh, it's going to be below 0, so I know that it's going to have a negative. Alright, slightly trickier. In Antarctica, the low temperature is negative 42 degrees Fahrenheit. The high temperature is 20 degrees warmer. What's the high temperature? A high temperature in Antarctica is still going to be pretty cold. But here we go. The low temperature was negative 42 degrees. And then it says the high temperature was 20 degrees warmer. Warmer is telling us a direction. It's telling us that the temperature is going up. So I'm going to use addition, and it's going up 20 degrees. So if you don't draw a picture of this, it can be kind of tricky. So I really recommend that you sketch an open number line whenever you want. Or you could even solve it with chips, but since we're talking about the temperature, I think the number line makes sense here. So the temperature starts at negative 42 degrees, and then it's going to go up 20 degrees. And I know that since the temperature's starting 42 degrees below, and it's going up 20, it's going to get closer to zero, but there's no way it's going to pass zero. All right? So one thing to remember is that when we're below zero and we're going up, it's getting warmer, but the numbers actually go down. And that's because they're telling you how far away from zero we are. The numbers go down as you get closer to zero. So one way to figure it out would be like, all right, so for 42 degrees below zero, and we're going to get closer to zero, we can actually subtract to figure out what temperature we're going to land at. And when we do that, we land at negative 22, and that's actually the answer to this problem. It's negative 22 degrees Fahrenheit. And as one extra way to look at it in case that was confusing, if you need to go up a total of 20, I know that if we were to go up 10 first, we'd go from negative 42 to negative 32, and then if we go up another 10 for a total of 20, we'd end up from negative 32 up to negative 22. Alright, so now the state test questions. Most likely, when you see integer problems on the state test, they're going to involve decimals or fractions just to make it tricky. But the helpful thing is you're always going to have some answer choices, and the answer choices will help you make sense of the problem. So yesterday the temperature at noon was 11 4/10 degrees. By midnight the temperature had decreased by 15 7/10 degrees. Okay, so in this case we have this high temperature of 11 4/10 degrees, and then had decreased, telling us that we're going to subtract, and we're going to subtract 15 7/10 degrees. All right, so looks like a pretty tricky problem, right? You might look at it and be like, oh my god, I can barely do it with regular numbers. How can I do it with decimals? So if you started though, like, don't give up, just start by drawing whatever you can, and then you'll see how they're actually giving you a big hint here. So if we're starting at 11 4/10 degrees, and we go down 15 7/10, I know that since 15 is bigger than 11, we're going to go past 0. So from here to here is going to be 11 4/10, and from here to here, we don't know what this is. That's kind of what we're trying to find. But take a look at our choices, right? I know that we're going down a total of this many, and we've already gone down this much, so we only have about 4 more degrees to go down, which means that this is probably going to be close to 4, negative 4. All of these answer choices then have to be wrong. The only one that makes sense here is this one. If you wanted to find the exact answer, you would take the number of degrees we're going down in total, subtract the ones that are in the positive, and then you'd see that this question mark is actually 4.3 degrees left, and you'd end up at negative 4.3. So my advice is don't give up on the problems if they look scary, ever. Start by doing what you know, and then look at the answer choices, because some of them are going to be ridiculous. They're not actually going to make any sense if you think about it. Alright, let's take a look at this one, which looks tricky, but really we can, again, figure it out like the last one. Scientists determined that Antarctica's average winter temperature was negative 34.44 degrees. The difference between this temperature and Antarctica's highest recorded temperature was 49.44 degrees. What was Antarctica's highest recorded temperature? Alright, So I think what makes this one tricky is it's hard to figure out if we're supposed to add or subtract here. Um, so let's start with what we know. We know that the average temperature was negative 34.44 degrees. And then it says the difference between this temperature and the highest temperature was 49.44 degrees. Um, so this is actually telling us that we need to add. And it's telling us this because it's asking about the highest, it's giving us this one, and then it's telling us that the highest one is going to be this much greater than it. So we would have to add that much to figure out what it is. And it really helps to see this on an open number line, because it's saying that this is the average temperature, and then the highest temperature is this much higher, 49.44 degrees higher. And then it says, what is the highest temperature? So we got to figure out what that equals. All right, so once you figured out that we're starting at negative 34-ish and going up 49-ish, the problem becomes pretty straightforward. Because if I think about it, I know that we're going to pass 0, but we're not going to pass 0 by too much, right? Because we had to go up 34 to get out of the 0, and then we're only going up a total of 49, so we only have a few left. So look at again how we can get rid of some of our answer choices. A makes 0 sense because we're going up, not down. B doesn't make any sense either because I know that we're going to make it above 0. C looks like it might be the answer. But let's find out. And then you go down to D, and D also doesn't make any sense because I don't have that much left to go up once I get to here. I only have this much to go up, which there's no way that's 83. And honestly, they put, don't circle it, that's confusing. So they put this answer here for kids who didn't think about integers, and they just added these two together and ignored the negative sign. So I know what the answer seems like would make the most sense. And now to find it exactly, I know that from here to here is 34.44 degrees. And then from here to here is what we're looking for. To find it exactly, you could take the amount we're going up in total, subtract the part that's in the negatives. And when you do that, we get 15 degrees exactly. So that's how much left we have to go. So the new temperature should be up here. It should be 15 degrees Celsius. All right, let's see your picture of this emoji. Do you like mine? I drew that myself. Okay, bye.